So while these conditions are up here, and you're seeing them, while these conditions are up here, I'm going to kind of focus in on the normal condition a little bit. Remember, our normal condition has changed from when we did proportions, it was n times p and n times 1 minus p for proportions. For means, remember our condition for normality is that n is at least 30. And I mentioned that n was not 30 this time. And so we needed to check some things. That's only if n is not larger than 30. If n is larger than 30, all you need to say is that n is larger than 30. So let me actually jump to like the last slide of the notes, which actually talks about this idea. So the idea is that this new distribution, which is called a t-distribution, is what we call robust. In that it is fairly resistant to outliers or skewness. So we can be a little lenient on our normal condition. How lenient we can be is dependent on how much our condition is violated. So if n is at least 30, then we're in great shape and the normal condition works no matter what. If n is less than 30, then we need to check. And how much we need to check and how strict we need to be depends on how large our sample size is. If our sample size is at least 15, then what we are looking for is no obvious skewness or outliers. If the sample size is less than 15, so we have a really small sample size, then our distribution needs to be looking very close to a normal distribution. So it has a single peak on it, it is symmetric, it does not have any outliers. Now, someone would look at that and say, hey, that looks pretty close to a normal distribution. When we're at least 15, we're fine as long as there isn't any clear skewness or outliers. If we're at least 30, then we're good no matter what. So another way to phrase this normal condition is that if we have large sample sizes, then it doesn't matter. Always normal, n is at least 30, we're good. If we have like medium size, that's between 15 and 30 as our sample size, then we're going to say that we're good unless we see some very clear indication that we aren't. Right? That's our clear skewness or outliers. If we're small sample size, less than 15, then the opposite is true. We're going to say our normal condition is violated unless we see some very clear indication that we're okay. Unless we see some very clear indication that it is normal. In other words, it looks really close to a normal distribution. So that's what we're going to use for the normal condition. And that's through checking our graphs on the calculator. Mostly our box plot and our normal probability plot. And we talked about how to get those yesterday. So that's our normal condition. Random and independent are the exact same as they were with proportions. All right. We went in our calculator, put the data into list 1, and got our one variable stats and found that here was our mean and here was our standard deviation. The next thing we need to find in our formula is the t-score. So let's go ahead and do that. Remember, the t-score needs two things. It needs our area, just like the z-score did, and then it needs degrees of freedom. So let's start with area. What is the area we need to the left for the t-score? It is 0.95. So inverse t, our area to the left is 0.95, the 90% in the middle for the 90% confidence interval, and then 5% for the tail. Degrees of freedom. How do we get degrees of freedom? We take our sample size and do what? We subtract 1. So our sample size here was 20, so we're going to take 20 minus 1, and that's 19. So the structure, if you have an older calculator, is like this. If you have a really old calculator, you might just need to use the table, which I'll show in just a minute. But then our t-score is going to be 1.729 is going to be our t-score. So our area to the left was the 90% plus 5% in the tail, so 0.95. Our degrees of freedom was 19, our sample size minus 1. So now we've got all the pieces we need for our formula in step 3. Here we go. First of all, it's showing in the table where to get our t-score. It's 1.729. Formula, plug in the numbers. So let me walk through that formula and plug in the numbers again. It's the statistic, which in this case is the mean, x bar, plus or minus the critical value. The critical value there is my t-score instead of the z-score, times the standard deviation formula, where the standard deviation formula for means is standard deviation, s sub x, over square root of n. And then we're plugging in all the pieces that we already know. Our mean is there, plus or minus. Here's our t-score that we got, times the standard deviation, which we got with one variable stats, over the square root of n, which is 20. I'm going to pause your writing and have you go to the calculator. Make sure your data is still in list 1 so that you can follow along with me here. If you don't have any data in list 1, then you're just going to have to watch, because having you catch up with what the data should be is going to take 5 minutes. And I don't want to waste other people's time. We're going to go stat over to test. The name of this test is going to be a one sample t interval. So one sample, because we're using one sample. T, we're using t-scores. And interval, doing a confidence interval, instead of a test, which we're going to talk about next chapter. So t interval, it's just labeled as t interval. So that's where we're going to go. And when we go there, they're going to have 2 different options here. All right, let me explain what the options are before you get bogged down by the menus. The 2 options are data and stats. And they're basically going to ask, do you just have the data? Do you just have a list of mean and standard deviation and sample sizes for me? And that's all you're given? Or did you have a list of all the data and you put it in a list and you want me to go from that list 1? So in the case of I just got a mean and standard deviation and a sample size for you, you're going to just plug in that mean and standard deviation and sample size, and then it's going to tell you the confidence interval. If you took all the values and put it into list 1, you're going to tell the calculator, I want you to do this for the data that's in list 1, and then it will do the rest of the calculations for you and tell you the confidence interval. Does that make sense? So on some of the problems, you're going to have a list of data that you put into list 1. On some of the problems, it's going to tell you, I had some data. Here's the mean, here's the standard deviation. And that's what you're going to put in the calculator. So in this case, we're using data because here's what the stats menu looks like, just so you see. It's going to be, here's X bar, here's our standard deviation, here's N. And you would put in whatever values you want. It actually automatically already has that there because we did one variable stats earlier. So it actually has all the data that you would need. But we're going to go over to data so that you can see how that looks. And all you need to tell it is, what list did you put all the data in? I put it in list 1. Confidence level, we're using a 90% confidence interval, so 0.9. Calculate. And in case you didn't already do one variable stats, it says, here's the mean, here's standard deviation, here was your sample size of 20. And then here's the confidence interval. So it's the same menu in the calculator. The place you're looking is going to be T interval. So once again, on step 3, the work you need to show is formula, plug in the numbers, answer. And then step 4 is going to be the interpretation. And interpretation, before you write down, listen. The interpretation is going to be the same structure that it was last time. Exact same interpretation. It's going to be, we are 90% confident that the actual parameter, which in this case is a mean this time instead of a proportion, so that the actual mean tension of the video screens, you should have written that part down in step 1, falls between, here are the two numbers. Or, the way the book likes to phrase it, we're 90% confident that the interval captures the parameter. It's just a different way of phrasing the same things. But same idea of what you need to say in the interpretation. Number 1, you need to say, we are 90% confident that. Number 2, you need to say what the actual interval is. Number 3, you need to say that the parameter, whatever it was defined as in step 1, is between those two numbers. So my structure of the sentence is, we are 90% confident that the parameter is between those two numbers. No, not there. Hold on. That's what I wanted to do. If your calculator gets the T-score, you do not need to write all this stuff for getting the T-score down. And all the stuff with the table, because we did it in the calculator. You should write down this part with the formula, plug in the numbers, answer. That's the part you need for step 3. questions on that? All right. Same four-step process. Yes. Except we're going to use some things for means instead of some things for proportions. So I'm going to be going on here. If you need something, it's in the video. But I want to go on because there are a couple things I want to show. First off, homework. I believe all the homework should be posted on Canvas now. This homework assignment is fairly long, just to let you know. Yes. And then here's the review, so you have it as well. There is not another one after this. Yes, these are all the homework assignments. Okay. Before I turn you loose to work, I want to just give a quick outline so that you can see, again, this. I did something similar to this in Chapter 7. I'm going to do it again in Chapter 8. And what I'm going to do is I'm going to outline the difference between the four-step problems that we talked about last week versus the ones that we're talking about this week. That's what I want to look at and outline. So, first off, you need to determine whether you're given a proportion or whether you're given a mean. Right? Proportions, usually it's either going to give it as a decimal between 0 and 1, and that's your p or p hat, or it's going to give a certain number of the people surveyed out of the total number of people. Right? That's how you know you're looking at proportions. Means, it'll probably say the mean and give you a way to get the standard deviation. Or it'll give you a list of numbers like it did on the last one. So that's how you can kind of get a clue as to whether you're working with means versus whether you're working with proportions. So with proportions, we are using p hat to estimate p. In other words, p hat is our statistic. It's what we get from the sample. P is our parameter, and we are estimating. So in step 1, you're going to say you're using confidence interval to estimate p, and you're going to find what it is. For means, you are using x bar to estimate mu. So again, x bar is what you're getting from the sample. Mu is what you're getting from the population. And so your step 1 is going to say, we're using a 95% confidence interval to estimate mu, and then you're going to define what mu is. So that's your kind of difference in step 1. Your difference in step 2. The name of this test is a 1 proportion Z interval. This is called a one sample T interval. So if you're dealing with means, you're going to call it one sample. And you're going to see the reason we're using this naming convention is that we're going to try and match what the calculator calls it as closely as possible so that you can easily find it in the calculator. So you're associating with the name of the test with, you're not memorizing a different name than the calculator, and then you have to memorize something different to find in the calculator. The only one that this isn't going to apply to is that this is just called a T interval in the calculator. Over here, the big difference here is that we are doing one proportion. So instead of sample here, if it's proportions, we're going to put proportion. Your random condition is the same. Is it a random sample? Your independent condition is the same. It's the 10% one. Take 10 times sample size. What is different is the normal condition. To check the normal condition, over here, we're going to check n times p hat and check to see if it's at least 10. And n times 1 minus p hat and see if it's at least 10. Over here, we're checking whether n is at least 30. And then everything else about step 2 is the same. For your formulas, standard error. In other words, the standard deviation formula. Standard deviation formula with proportions is the square root of p hat times 1 minus p hat over n. That's a formula that's going to be on the formula sheet. It is given to you. You don't need to memorize it, but you need to associate it with proportions. Over here, the standard error is s sub x over square root of n. And then the last big difference is critical value. When you're doing proportions, your critical value is going to be your z-score. And so in the calculator, you're going to use inverse norm. For means, in the calculator, you're going to use TScore. And remember to get your degrees of freedom. And you want to write that down in your step 3. It's a part of your calculations for how you're getting your T-score. You need to show degrees of freedom equals sample size minus 1. And you see this in the name of the interval, too. This one's called a Z interval. This one's called a T interval because we're using T-scores instead. And then step 4, the interpretation is going to look the same no matter what. So these are kind of the differences, highlighting the differences between each of these two types of intervals. Questions on any of that?